Okay, it's going. All right, so the section that we skipped was inequalities. And the big thing I want you to remember from inequalities is that if you multiply or divide by a negative, your inequality symbol flips. Okay, remember that? That's in Canvas if you need a refresher on just plain old inequalities, like 7x is less than 14. Okay? Now, if it was negative 7x is less than negative 14, then we would flip the inequality symbol when we solve it. Sound familiar? Kind of. Okay. That's the big thing I want you to remember. Okay? So,
why are we not doing section 5?
Section 5, because it's all about solving just plain old inequalities. So, it really is solving things like this. I can go over 1-5 really fast. It would be like, and then you solve that guy, right? Yeah, we've done that, right? Okay. The only thing that I want you to remember is if it's a negative, that guy flips. Yeah. Okay. There's 1-5 in a nutshell. Oh, I guess the other thing we could talk about is graphing, right? If I were to graph that guy on a number line, this guy right here would be an open circle, and it would go to the left. I want things that are smaller than 2. If it had the equal sign with it, we'd shade it in because it includes the 2. Thomas?
But they wrote the graphs again, like dotted with.
Yeah, so we're going to get to, when we do it on a coordinate plane, if it has the equal sign with it, it's solid. If it doesn't have the equal to with it, then it's going to be a dotted line. Yeah. So, like this guy right here, if we were to graph this guy, I'm not a crazy stickler for your number lines. If it has 0 on it and your number, I'm happy you don't have to put everything in between. So this guy would be an open dot, and I want things that are bigger than -2. So he would go to the right. And then if it had the equal to with it, then we would shade it in. Does that look familiar? Everybody good with that? Okay, any other questions on stuff that I just skipped? Okay, perfect. All right, sometimes we get inequalities where more than one thing is happening. Okay, so if you notice at the top of your page, we have and inequalities and we have or compound inequalities. So in an and, both of them are true. In an or, one or more are true. And you're going to say, how do I know the difference? How do I know if it's an and or if it's an or? Look at number 1 compared to number 2. It actually says the word or, right? This guy has 2 inequality symbols and they're written all together at once. That guy's an and this guy is an or. Okay, both of these are true. One of these or both of them are true. Does that make sense? That's true or that's true. Okay, so let's think about how to solve this guy. Let's go ahead and separate this guy apart. So we have one inequality here, and I'm going to take it to the first inequality symbol, this guy right here. So 10 is less than or equal to 3y minus 2. The second one we have is this guy, and 3y minus 2 is less than 19. So 3y minus 2 is bigger than 10 and smaller than 19. You see that? Okay, let's just solve them one at a time. Let's solve this guy. Add 2. 12 is less than or equal to 3y. Divide by 3. So 4 is less than or equal to y. Okay, before we graph it, let's go ahead and solve the other side. So I'm going to add 2.
And on the first one, the inequality symbol doesn't flip because we didn't divide by negative.
Correct.
Okay.
This guy was a positive 3, so we didn't flip him. Okay, divide the right guy by 3, so y is less than 7. Okay, now, if you leave your answer like that, technically that's true and I'm okay with that. Mathematically speaking, we pulled it apart, right? We duplicated this 3y minus 2 for each one of them. So when you solve it, we've technically duplicated that y. So when we write our answer, we should technically squish it back together. So my answer is 4 is less than or equal to y is less than 7. That's the proper mathematically way to write that guy. Now, I gave you 3 number lines over here. Technically, you don't need all 3. I'm going to show you why I gave you 3 so that you can see it. But really, when we graph it on a number line, you only really need 1. Okay? So, if you think about this first guy right here, is 4 is less than or equal to y. Alright, so I'm going to put 4 on my number line here. And I want numbers that are bigger than or equal to 4. Okay, so he's going to be a closed dot on 4, and he's going to the right. Okay. Well, if I do my middle one as y is less than 7, well, there's 7. We'll keep 4 on there just for reference points. So I want numbers that are smaller than 7, and not to include 7. Well, it was an and, so both of them have to be true. So the bottom one, you can think of as your answer. I have a closed dot on 4, an open dot on 7, and it's everything in between. It's where they overlap. Okay? So technically, you can do them all on one number line, and that's okay with me. And you should end up with an interval. Okay? You have one. I have to see if you can see it. My hand signals for those at home. You should end up with an interval. Okay? One endpoint, and they should meet. Okay? When you have an and. Okay. Number 2, we have an or. Let's see what happens, and I only gave you one number line this time too, and you'll see what happens when we graph an or. All right, so let's solve both of them. Questions so far? Sorry. Okay, let's solve the first guy. X plus 3 is less than 2. I'm going to subtract 3. So x is less than negative 1. Flip it, right? On the next one, we have a negative x. So I have to flip that guy. Yeah, we added and subtracted. Yep. So now this guy is x is greater than or equal to positive 4. Okay, so let's graph on our number line. We have a negative 1 and a positive 4. If your variable is on the left, your inequality symbol will point in the direction your arrow needs to go. Okay? If your variable is on the left. So I have an open circle on negative 1, and I want numbers that are smaller than negative 1. Those are to the left. This guy has the equal sign with him. So I have a closed circle on 4, and I want numbers that are bigger than 4. So he's going to the right. So either my numbers are smaller than negative 1, or they're bigger than or equal to 4. Does that make sense? So with an or, you usually end up, I'm zoomed in too far, but with an or, you usually end up with something like this. Okay? Think about a boat. Very rarely, and in fact, and never in here, will you end up with an or that does this. Okay? If you're rowing your boat's not going to go anywhere. So usually with an or, you end up like this. Okay? They usually don't end up going in the same direction. Not for me anyway. Now, I'm not going to say never because you're going to get to a point in math where that could happen. Okay? So, usually when we have ants, they're like this. It's an interval in between. Or, think about oars on a boat. They go out. Occasionally, you'll end up with a special or that does this. Okay? Think about a number line. This is a special or. If you end up with an or and they cross like that, is there any number that's not included? No. So if you end up with an or where they cross, it's all real numbers. That could happen. All solutions, all real numbers. Anything is possible. Okay? Yeah.
Would negative 1 3 not be possible?
So this guy is covered by that guy. This guy is covered by that guy. So it ends up everything is possible. Yes. You know what you're saying now. Because this guy technically starts there. Yeah. But it ends up the other one covers it. Yeah. Okay? Alright, questions about ands and ors? Because I'm about to throw one more thing at you. Okay, so we've done inequalities. We've done compound inequalities. We've done absolute values. At the bottom of your paper there, we're going to squish them together. We have absolute value inequalities. Let me see if I can zoom back in. Remember, an absolute value means its distance away from 0. So I can go in the positive direction or I can go in the negative direction. So with absolute value inequalities, we end up with compound inequalities. So this guy right here says if the absolute value of A is less than B, then negative B is less than A is less than B. Is this guy an and or an or? Do you see the word or? No, so he's an and, right? Okay, then it says if the absolute value of A is greater than B, then A is greater than B, or A is less than B. So, if we have an absolute value, and it says I'm going a distance smaller than B, then I end up with an and. If I have an absolute value and I'm going a distance greater than B, then I end up with an or. Okay, let me show you how that works with some pictures, okay? So this guy right here, he's a less than. So when we graph this guy, we should see an and. All right, so it says the distance of D from 0 is less than 3 units. Okay, let's draw a picture of that. All right, here's 0. There's positive 3. There's negative 3. I want to go a distance smaller than 3. Okay, what about here? If I were to pick a point here, is that a distance smaller than 3? Yeah. How about over here? Is that a distance smaller than 3? Yeah. What about a point way out here? Is that a distance smaller than 3? No. Over here? No. So, it doesn't have the equal to with it, but anywhere between those two guys works. Anywhere between them is a distance smaller than 3. Look at what we graphed. We graphed an and. Okay, well the next one is a greater than. So it's a greater than, it says I should get an or. Alright, let's see if we get an or when we graph this guy. So the distance of D from 0 is greater than 3. Alright, there's 0, there's 3, there's negative 3. We just discovered on the last one that anything in here is a distance smaller than 3. So that's not bigger than 3. That's not a distance bigger than 3. But out here, this is a distance bigger than 3. And out here, that is a distance bigger than 3. So, he looks like that. So we got an or. Anytime your absolute value is less than 3, you'll get an and. Anytime your absolute value is greater than 3, you'll get an or. Or not, I shouldn't say 3, but just greater than, okay? Okay, so let's practice this. Number 5, it says the absolute value of 2x minus 2 is greater than or equal to 4. All right, so let's look at my symbol right there. It's a greater than. So this guy's going to be a an or, excuse me. Now, we could go up here and try to do all this stuff. I'm going to show you the quick and dirty way to set it up, okay? Just like with absolute values, we're going to separate it apart into 2 equations. So, 2x minus 2 is greater than or equal to 4, or 2x minus 2, here comes the trick. Flip your inequality symbol and flip your number. You have to flip both. Okay, so now let's solve this guy. 2x minus 2 is greater than or equal to 4. 2x is greater than or equal to 6 when I add 2. Divide by 2, so x is greater than or equal to 3. Let's wait to graph till we're all done, because we don't know what our other number is going to be. Alright, I have a negative 4. I'm going to add 2. So 2x less than or equal to negative 2. Divide by positive 2, so x is less than or equal to negative 1. Okay, my 2 numbers on my number line are negative 1. I'm going to throw 0 on there. And 3. The 3 has the equal to with it, so he's closed. So I have a closed dot on 3. I want things that are bigger than 3, so he's going to the right. I have a closed dot on negative 1. And I want things that are smaller than negative 1, so he's going to the left. Did we end up with an OR? Yeah, we certainly did. Okay, last one. Questions before I do the last one? Okay, number 6 says solve the absolute value of 2y minus 5 is less than 3. Less than, I want to go a distance smaller than 3. So this guy's going to be a and. We do also have to flip this one. So 2y minus 5 less than 3 and 2y minus 5 greater than negative 3. You have to flip both again. So the nice thing is the process doesn't change for that. Flip the inequality symbol and flip the sign. So no matter if it's an and or if it's an or, you're going to flip the inequality symbol and flip the sign. Okay, let's solve. 2y, add 5, is less than 8. Divide by 2, so y is less than 4. On the other one, I'm going to add 5. 2y is greater than negative 3 plus 5 is 2. Divide by 2, so y is greater than 1. Okay, now, remember at the top when we were doing compounds and I told you to squish them back together? This is going to take a little bit of practice. So, this technically is our answer down here at the bottom, and I'm happy if you leave it like that, okay? But I want you to get in the habit of writing ands as all 1. So, which one's smaller, 4 or 1? 1, okay, so we start with the smaller number. He goes on the left. The bigger number goes on the right. Your variable goes in the middle. And crocodiles always eat what's right. They never eat leftovers. Crocodiles always eat what's on the right. They never eat leftovers. Really technical term, calling it a crocodile. Draw you my crocodile. Okay, so that's how I remember it. Small number on the left, big number on the right. Crocodiles eat what's right. They never eat what's on the left. Okay, bless you. Sneezing in those is not fun. Okay, so if you look back at this guy, it's the same exact thing. Remember the crocodile was eating the 4, here the crocodile's eating the 4. The crocodile's eating the y, the crocodile's eating the y. Okay? I want numbers that are smaller than 4 and bigger than 1. It didn't have the equal to with it, so I've got open and it's in between, which we knew we'd get because it's an and. We want a distance smaller than 3. Okay? Okay, questions on any of that?